So before we begin, I would like to know, like, how many of you have completed your hands-on, like setting up your Git, running the basic commands, exploring the working directory, staging area. Have you all done that? So Magesh have completed that. Swapnil have completed. How about others? Whoever have completed can raise your hands. Okay, Mukesh, Anvesh have completed. Sai Dishwar, Susetra completed. Pavan have completed. Not bad. So, expecting the same with everyone. Like two more guys have raised their hands. So, not bad. So, everyone have to do this, right? Like from day one, please get started with your hands on. In the day one, it might be the very basics because that's how we should begin. Before learning anything huge or anything for that matter, that's how we should start from the basics and the fundamentals. I'm glad that you all have completed it. Whoever haven't, like majority have done that. Whoever haven't, please go through it and uh, complete your hands-on, right? So before we jump in, let me just show you this architectural diagram. Yesterday we were talking about this working directory, staging area, local repository. I would like to remind you at this point, we did not go to remote repository set. We did not go to remote yet, right? We were still on our local repository. There are many things we need to understand about local repositories before we go to remote, right? So let's get started. Now I'm in my project directory. So go to your project directory. You may give whatever name you want for your project and just go here and do ls. Like I have couple of files and git status. So today, before exploring new things, I would like to show you one more interesting thing. Let's suppose I want to edit this file, right? I'm going through the Windows Explorer, right? Uh, and then open the file and modify it. Or else you may use some Linux editors, anything. Or else if you are a Windows person, you might be using Notepad. This is how we are doing, right? Going to that file location, open that and edit that using Notepad or Notepad++ if it is Windows. This is how we are editing, right? There are some professional editors which can help you edit your files, manage your Git repositories better, right? So let me show you that editor. Just go to Google and type in VS Code editor, VS Code download. VS Code is nothing but an editor. So if you go to this website, Visual Code Editor, Visual Studio Code Editor, VS Code Editor, right? This editor is available for Windows, Mac, and Linux as well. So according to your operating system, you can download it. This is an editor which everyone can use, a professional one, particularly as a DevOps engineer, you can use it for managing our Kubernetes manifest files and all. So just download this editor. Once you have this editor downloaded, like you can just double click to launch it. And this is how it looks like. And here you may open, just maximize this and go to file. Open your folder, which is your Git project. This is Git demo, right? Open this. So this is the one. Right? Initially, you will see nothing and you can go to file menu and open the folder, whichever you want to version control it. Like, see, again, I'm telling this is nothing to do with the Git or Linux. This is just an editor. Like you have Notepad, Notepad++, Word documents or notes in Mac and all. This is an editor which can give you an ease to edit and manage your files. See, you can click here and just make the modifications here so that it's more convenient. And this is the most widely used one in reality also to manage our DevOps config files. So another important advantage of this is if you go to terminal, you can launch the terminal here itself. Need not necessarily launch a separate window like this. Everything goes into the same window, which is quite convenient to use, right? So this is how you can use. And again, see, we are present working directory will show you where are you. Like we are in this particular folder. So perfect. You can run any commands. It's nothing but your terminal, right? So now that we are already here, let's get into the new concept. Good to go. That's an editor to edit the files. That's all. A better editor which will help or which will ease the work. Now let us get into some interesting thing. Already file 3 is there. And let's say I'm adding some line to this file 3. Can you tell me where is this modification? Yesterday we have spent some quite some time over this. So where is this modification? Or where is this change? Yeah, whoever raised the hands or unmuted. Or you can use the chat window as well. Okay, there were a good number of answers. Okay, yeah, working directory. Correct, correct. So the change is in the working directory, right? So if you see the status, it would show us like this particular change is in the not stage. Not stage means unstage. So if you want to see unstaged changes of any file, git diff file name will show you the unstaged changes of the file. Do you see that? So this particular line is unstaged. So this is another new command, git diff file name will show you unstaged changes. Okay, fine. I would like to stage this. Git add dot or git add file name. So git diff, is it having, I have already added. Now, is this having any unstaged changes? Is this file having any unstaged changes now? Correct, Suvati. Yes, this doesn't have any unstaged. I just added it. So that's why git diff file name is not giving you any input because there are no unstaged changes, right? Later on again, I'm adding a line. Now tell me, is it having unstaged change or not? Right? It is having unstaged change, which can be seen this way. At the same time, it is having staged change also. Isn't it? First line is staged. So git diff staged file name will give you the staged change. Is that making sense here? This is staged means after adding first line, I have run git add. So it is staged. Then I have again modified. Means the same file is having both the staged and unstaged changes. Some of the changes are staged. Later on, we made few more modifications which are unstaged. Understood? Is this clear for all? Are we good? So it depends on how you are modifying it. Let's say I might have added some 2 to 3 lines and then I may have staged it. Later on, again, modifications may be happening. So the same file could be having some stage, some changes staged, some changes unstaged. This is having unstaged changes as well, right? This is staged change. First line is staged. Again, I added second line, which is unstaged. That's what it's showing. So same file could have staged and unstaged. At this point, when you run git status, see, the same file, file 3 is shown under staged. Do you see this? Changes to be committed means where are the changes? Changes to be committed. Refer to the architectural diagram always. Changes to be committed means where are those changes?
In the staging area.
In the staging area. And there is another message, changes not staged, means where are those changes?
In the PWD.
Right? So in the working directory. So the same file could be there both under staging and unstaged. At that point, you would see like this. Same file shown in the staging area, same file shown under working directory. So don't get confused. This could be the scenario. Is the scenario clear for all of you? A real use case where a user might be making some modifications, might have staged them. Later on, the user is coming back and making further modifications. Right? So that's where it is. Now you have to add and commit, right? Because it is already an old file, we can do with a single command -am file or else, sorry, commit message, right? File modification. Got it correct? Any questions on this particular use case from anyone? All right, thank you all for confirming. So now let's talk about another interesting use case. Like till now we are creating files, modifying the files. How about deleting a file, right? So let's see how to delete a file. Let's suppose I just want I want to remove a file both from staging directory, both from staging area and local repository. That's where comes git rm command. So let me try doing this git rm. Git rm file3, let's say, right? So you can see file3 is gone. And if you see the status, like I told you, right, anything is a change. Git works with respect to changes. Creating a file is a change, deleting a file is a change, modification is a change. So every change will go through the same process, right? So now the changes are to be committed, it is saying to be committed. So let's do a commit, git commit -m deleted file3 from both working directory, sorry, staging area and local repository. Right? So gone. Now if you do ls, file is not there in the folder also. At the same time, git ls files, which will list the files and folders in the local repository and staging area. And status would also be clean. Like whatever changes we have done are all committed. Right? So this is what you have. And then this is file is gone. And there is another way to delete a file, which is git rm cached. And then let's say file2. What is this about? Means rm cached is, yes, I want to delete a file, but I want to delete it only from the local repository, but not from the working directory. Means I don't want to put it in the local repository, but I still want to keep it here. I want to keep it in this folder because maybe that's a documentation for the project, which I want to keep it in the same folder. Still, I don't want it to get version controlled, right? So in that cases, we can use rm cached file2. Right? Yeah. So let us try deleting it. So you can see file is there in the working directory, but let me show you. ls, yes, it is there. Git ls files. See, it's no more in the staging area and working directory. Staging area and local repository. Do you notice the difference? Right? Also at this point, if you do git status, it's showing us this changes to be committed because we made some delete, we should commit it, right? So like before, just commit git commit -m deleting file2. Okay, so done. Now just do the status. Why it is still showing like this? Why it is shown as untracked? Anyone? We have deleted the file. It's no more in the staging area and local repository. Git ls files is not listing it. But what does it mean? Why was we seeing this?
Yeah, it was in the present working directory.
Exactly. It's in the working directory, right? So it was like a new file. That's why it was like untracked. We removed it from local repository and staging area, but still it is in the working directory. Whatever present in this Git demo, in this folder, will be version controlled by Git. Isn't it? This Git demo is a local repository. We did Git in it, and this folder has got a .git, right? So it will version control whatever present in here. Isn't it? So that's like a new file again. That's why it's being shown as untracked. Right? Hope you're all with me following. So now, okay, fine, this file is present, right? Like this file is present in the working directory, but not in the local repos. That's fine. But it will be keep on showing this message, right? It will be always telling me to add it because Git will be tracking whatever files present in here. So it will keep on asking me to track this. So, which is like the expected one. Okay, fine. But let's suppose, correct, this is a project document, so I have placed it. But let's say this is like a notes or a project documentation, and I don't want even Git to track this like this. I don't want Git to keep tracking this, right? But I want to keep it in the same folder. But as long as you keep it in the same folder, because it's a local repository, it will be keep on tracking and giving us this message. But assuming it's a personal notes I have taken for this project, or else it could be some log files generated, or else it could be some exe, which need not be version controlled. Means how to tell Git not to version control, not to track certain files present in the working directory. Is it possible? Means in simple, how to exclude certain files from getting version control. Whatever present in the folder will be version controlled. That's the meaning of local repository. But in case the use cases like log files, documents, or some project documentation, which should be present in the folder, but still keep muted, everyone. So, how to tell Git not to version control certain files? Anyone, any idea?
By using RM command, we can delete it from the local repository so
I
that it
want
will be
to keep it in
present
the
in.
local repository. That's the point. I want to keep it in the repository. It's a document which I need it, but I don't want Git to version control it. I want this document. It's important. It's a log file or something, but I don't want Git to track it. That's where comes another concept called Git ignore. That's where comes something called Git ignore. Somehow the marker is not coming. That's okay. So Git ignore. What do? Create a file. Go here. Using this VS Code editor, you can create a file from here. Create a new file. Name it as .git ignore. .git ignore is a Git object. So this is a file. Now you can put the files whichever you don't want to get version controlled. See, I have added file 2 and saved the file. As soon as you add this file name, do you see it is grayed out? Do you all see the difference? Please raise your hand if you want to confirm. Do you understand this? Have you noticed it? Right? It is grayed out already. It's not been version controlled anymore. Also, if you run status now, see, it's no more bothered about file 2. But .git ignore is also, after all, another file. Right? It's also another file. So it would be version controlled. So you have to add .git ignore like any other file. Git add .git ignore. See that this is another advantage of Visual Studio Code. Here you can see when you keep the cursor, it says index. It means it's in the staging area. U means it's untracked. So here it will show you the status. git commit -m ignore file added. Ignore file added, right? So you can see here. Right? So we can see ignore file added. Right? It is no more tracked. ls file is there, file2 is still there, but it would not be tracked. Git ls files shows the files in the working day, local repository or staging area. Git ignore is there. Understood what git ignore does? Another interesting thing is, let's say you have so many log files. You want to ignore all those log files. Let's say they are with extension .log. You can use wild characters like star. Star means all the files that ends with the extension log will be ignored. You can do that, right? So you can use wild characters to match multiple files and all. Any questions in the git ignore part? This is very important. Where do we use it? Some of the use cases are like I'm talking about. You would be ignoring some log files, some executables which need not be version controlled. And from DevOps perspective, DS store is relevant to some internal file for Mac systems, Ramakrishna. You can ignore it. You have nothing to do with that. Right? And now, how is it relevant to us? See, here we are using ignore just to ignore some random text file, right? But when you talk about our our projects like Terraform, when you talk about Terraform, there are some files which are generated automatically called state files, which will have the state of the infrastructure. Those state files can be ignored using this. Similarly, in like in Kubernetes, you have secret objects. Even those can be ignored because they're confidential. You don't need to version control and share it across. Similarly, in Ansible, the passwords will be there, Ansible Vault and all. So even those will be ignored. So these are all the same concept would be applied in Terraform, and we'll see how it works, how it ignores state files. Concept is same, everything is same, just the file names, files are different. Understood? So that's a implementation of git ignore. We will use this, like we'll replicate these scenarios once we get started with those tools. Okay. And then git status, it's clean. And git log, if I see by now, there might be a bunch of commits. A commit history is shown in the log command. What if you want to undo any particular commit? What is meant by undo? What if you want to undo any particular commit? What is the dictionary meaning of undo?
If you delete anything, changes anything in the directory, if you do the undo, then it will come back again.
Yeah, undo means like if something is done, you are reversing it. Let's say we created a file. Undo means file will be deleted, right? Let's suppose you have deleted a file. You undo means file will be created back, right? A reverse happens, which is undo. So now similarly, you can undo any particular commit, which is called revert, right? You can undo any particular revert. Like let's say, uh, let's talk about this commit ID is there, right? This one. I can't refer the entire ID, so I would say, okay, that's a commit ID. I would undo. So what happens is whenever you revert, another commit ID B will be generated. Means let's say here you created a file. Commit ID, new commit ID B will be generated and file will be deleted. Again, let's say you want to get it back. Again, undo this B. Again, file will be back. Right? So when you just revert, a new commit ID B will be generated. When you revert this, another one C will be generated, but C would be at the same point as A. A, B, C are commit IDs. I can't refer the entire ID, so I am doing this. A, B, C. Right? So let us do the hands-on for this. Yeah. So what is the command? Git revert this particular commit ID. Revert also works like commit. Do you remember commit command? Git commit. We'll provide some commit message. Same is the case here. When you run this command, it will give prompt for some message, right? So let us run this. See, you will be entering into an editor where you can give some message. This is a Linux editor, a Vim editor, right? How do you edit this? See, at the bottom, you are seeing this, right? Escape I. Escape I means you will go to insert mode. Insert mode means you can type anything here. Here is nothing but the message. Let's say reverting. Ignore. Actually, in this particular comment, ignore file is added. I'm reverting means ignore file would be gone. Okay, I have placed the message. Again, escape, colon, WQ, exclamatory. We'll save and close the file. Right? Done. Now, if you see the status, okay, not status, just first let's check the log. Yeah. Do you see new ID is generated here with the message we have given? And now if you see the status, how come this is back again? Why it is being tracked again? Do you see here? Why is file 2 tracked again? Yes, why are we seeing this file 2? Because ignore file is gone. Because ignore file is gone, it's tagged, it's getting tagged again. Right? In this commit ID, ignore file is created. I reverted it, ignore file is gone. So because ignore file is gone, file 2 is being tracked. It's just like again a new file. Is everyone clear with the use case and the commands? Right? So now let's suppose I want to get the ignore file back. Can we revert this revert again? We just discussed, right? You can revert this revert again by git same command. This time this is commit B, right? So another commit ID will be generated and ignore file should be back, right? Let me run this. See, you enter this editor, escape I, you go to insert mode, give whatever message you want here, like reverting, ignore again, or reverting again, whatever it is. And again, escape, colon, WQ, exclamatory. So a new commit ID might be generated, clearing the screen and then check the log. So we have got here this part git ignore file added, reverting ignore, and then reverting again this ignore, right? This is like commit A, commit B, commit C. Because ignore file is back again, it's not version controlling file 2. Check the status. You will not see anything with the file 2. Isn't it interesting? Any confusions? Is that clear for all? Thank you for confirming whoever have raised the hands. How about others? Are we good to go? You can raise your hand or thumbs up and confirm so that we'll proceed, or any questions you can raise your hand so that I'll unmute you. Okay, Ram is asking to repeat again. Which part, Ram? See, okay, let me explain you this one. Like, this is your initial commit ID A, right? So which is where you have created ignore file, right? We have reverted that, and this is the commit ID generated. Let's say this is B. Initially in commit A, we created ignore file. Ignore file is created. So here ignore file is deleted, right? So then we have reverted it again. This is the generated ID after reverting again. Commit C. Again, ignore file is created, right? So in this ignore file, when you created it, file 2 is no more tracked, is not tracked here, right? It's no more tracking even though it's present in the working directory. But as it is there, I mean, as the ignore file is deleted, file 2 is tracked again, right? Here again, ignore is back, file 2 is no more tracked. Got it now? Ram, and how about others? Is the scenario clear for everyone? So this is what happened. And the command is, this is the command. Let me show you the commands. This is the command. Git revert that particular ID, that particular commit ID, like git revert A. Then new commit ID B is generated. Then git revert B. Another commit ID C is generated. A is if file is created, in B it's gone. Then again I reverted B, again file is back. So that is about revert. Revert works like a commit. This is very safe method to undo the things, because in the project you keep on modifying the configurations, then you may be changing it, you may want to undo them, right? That's where revert is used. It's a safe method to undo the changes. There are other ways to undo the changes. We will talk about them. Is this much clear for all of you? All right. So let us look into the next use case, which is a very interesting. Um, Again, let's go to the log one line, which will show us the brief log. This is the commit history. We are having some bunch of commits, right? Like let's say some 10 commits or whatever. Let's say at some point I realized I don't want top 4 commit IDs. Top means, see, you have this commit history, right? There is some pointer called head in Git. There is a pointer called head. This pointer head always points to the topmost commit into the branch, right? Like this is the topmost or the latest commit, and head would be pointing there. Now, let's say I realize I don't want these 4 changes, 4 commits, whichever I have done. I don't need, in the sense, I want to discard them from the commit history, as well as I want to discard all the changes that went into these commits. Let's say in these commits, 4 files might be created, 2 files might be there, whatever it is. If I want to undo a successive commit IDs, that's where we'll have this something called reset, right? Reset, as the name says, it will reset the head pointer. Let's suppose I don't want top 4 successive commit IDs. And then this would be the topmost one, right? So head will be pointing here. Right? Head would be pointing this one. So that is what is reset. Right? I don't want this. When I don't want, maybe let's say client requirement changed, or we just don't want the infra changes which I have done for last week. I don't want to maintain them in the commit history also. That's where this reset comes in. You can undo any bunch of resets, any successive resets, and the command is git reset hard head. How many number of commits you want to undo or get rid of? Let's say top two. Top two means DC09 will be the head pointer will be pointing, right? Or else let's say top four. Then, like we have seen, head will be pointing to this particular commit ID. That's the reset, right? So let me run this git reset hard. So you can see now head is at 11,829. This is the one. Also, when you check the log, all the commit IDs are gone, wiped off from the commit history, as well as whatever changes happened during there were all gone, right? So this is one of the ways to do reset. Let's say you want to reset again. Yes, you can do that. Git reset hard. This time, let's say I want to get rid of these two. Head tilde 2, or else after resetting these two, my pointer would be pointing here. I could also put here git reset hard. Right? Both the ways. You can do either ways. You may say head tilde 2, or you may give the commit ID which becomes the topmost one. Right? Let me run this. See, head is now at OE3. So if you check the log, yes. Right? So see this here, changes are also happening. Do you see? It will discard those commits, means whatever changes happen during those commits will also be discarded. Right? Do you get the difference? And reset is also to undo the changes. Then what is the difference between revert and reset? Revert will always generate a new commit ID, right? But reset will not generate any new ID. If it generates a new ID, you can revert that ID again and revert the revert kind of, right? Whatever you call it, revert a particular commit ID or revert this revert ID, you get the changes back. Safe method to undo. But if you do reset, changes gone are gone forever. You cannot recover the changes because it's not generating the commit ID. If you have some commit ID, you could revert that and get them back. But that's not happening either. Right? Is that making sense, everyone? So, yeah. So it's a safe, and here a reset command can help you recover the things, but revert is not. So which one should you use on regular basis?
Hi, Preeti.
Yes.
Uh, uh, Hello.
Yes.
Yeah, we did git reset for that commit ID, right? So, what is the use of that to make commit ID as a head in the every file, like second or third file? What makes difference?
These are
Why
not
we?
file.
Yeah, why we doing like that?
These are commit IDs,
Yeah,
right?
why? Yeah.
These are commit IDs I have done for a month. Then I realized whatever I have done last 1 week, I don't want it, right? These are the things I have made from last 1 week. I want to discard these completely, right? I
Yeah.
don't want a bunch of commit IDs. Whichever I have done, I want to just get rid of them. I don't want the changes that happened there. That's where you do reset. When I do discard these three, this becomes the topmost. Your head pointer is moving to this particular commit ID.
Why you want to move that particular head pointer to that
My
particular?
focus is not to move the head pointer. My focus is to discard these changes because I don't want them. What happens at the back, I'm telling you, when you discard these, head will be, means this becomes the topmost. History is the where head is pointing to. Head is some pointer in Git. When you discard these things, this becomes the topmost commit in the commit history and your head is pointing there. My focus is not to change the head. My focus is to discard the changes which I don't need. When I am doing this, this is what happens at the back end.
Okay, got it now. You just confused here. You given that git reset hard the commit ID, right? So I thought to UI you given the particular commit ID to pointer as head. So I got it now. Whatever the we removed first or second commit ID, it automatically comes into the
I
next.
am giving this commit ID means whatever above that will be gone. Or
Yeah.
else I may say head tilde 2. Two ways to do it. I may do head tilde 2 or else I may just give this ID straight away. Whatever above that will be discarded.
Okay. Yeah, got it. Thank you.
There is a question from Pediraju. Where do we use reset command? If you want to discard a bunch of commits which you have done over the last week or else last 2 weeks or else a month, then you realize the requirement has completely changed. Whatever you have done is no more needed and you want to discard or wipe off them, that's where you do reset. On regular, on day-to-day basis, revert is the one which is used. This is the one safest way to undo the changes and this is the best one. This is very rarely we use and this is very powerful and destructive command. Changes gone, once gone or gone forever. You cannot get the changes back again if you have done reset. Whatever changes are gone now, I cannot get them back. Whereas in revert, yes, I can keep reverting the revert ID and I just can revert to at any point.
So when we are using, we should use this command very carefully.
Yes, very carefully. That's why it's a destructive, powerful, very rarely used. Revert is the one which you should use. Any more questions on this reset? Whoever raised the hands are unmuted, you can speak up. Okay, there's a message from Swapnil. If we use revert command, code content or logs is not going to. When you do reset, these are wiped off from the log history as well as the changes are also gone. This is what I'm stressing from the beginning. You are wiping them from the log history as well as whatever changes are gone. See the changes at the back end I am saying. It's like a revert. Functionality wise, if let's say in this commit file is created, it's gone because this is wiped off from the log history. This is no more. It's at the same time, whatever changes happened in this commits are also gone. You cannot get them back. Changes, you cannot get them back. At the back end, you see ignore file gone. File 3 is there because I just reset all the latest ones. In the older commits, file 3 is there. You got it. Commit IDs will be discarded from the commit history as well as whatever changes happened during these commits will be gone, will be wiped off. Any more queries on this? So revert is the one which we should use on regular basis. On day-to-day, we use revert, not reset. Reset, like I said, if you are very sure, okay, last 1 week changes are no more needed. You are very sure and you don't want to maintain in the log history, you can just use reset. And reset will not generate a new commit ID, so you cannot get the changes which were lost. Right? Hope the difference is clear for both now. The differences between both of this, revert and reset. There were in the quiz, you see, there were questions related to this revert reset as well, right? So that you can register your understanding. You can validate your understanding by going through the quiz. So that is about reset and revert. I'll show you another interesting part and some additional thing here, right? Git log. One line. I have some bunch of comments. We are doing this reset hard, right? There is also other types of resets like reset soft, reset hard, reset soft, mixed reset. We don't use them and they're very rarely used. But I would like to give you a very easy way to understand them because reset is a far advanced concept and it would be a bit tricky or confusing. So when you come across other types of resets, you shouldn't get confused. Also, even though it's a complex subject like reset thing, this chart will simplify the concept. So if you have this chart, you should be comfortable understanding any type of reset. So I'll not get into hands-on of it because we don't use them much. But from the perspective of your interview, kind of, this chart will help you understand it very well. So let me show you different types of resets. We have seen hard reset. There is something like soft reset, mixed reset, right? In the command is same. Instead of hard, you put soft or mixed. So what is the difference? If you do this hard reset, your changes are gone from everywhere, right? You cannot get them back, right? It's all gone. Soft reset is your changes will be gone from local repository, but still they'll be present here. In that case, if you want to get the changes back to local repository, what you should do? Yes, in this case, what should we do? Exactly. Correct, Suvati. You should commit them, right? So that you get the changes back. That's a soft reset. And mixed reset is your changes will be gone from staging area, local repository, but they're still present in the uh, working directory. So how do we get the changes back if they're present in the working directory? Yes.
Revoke.
You are unmuted, Mukesh. Raise your hand so that I can see you and I can unmute you. We have to add and commit. Add, commit. You get the changes back, right? So those are the three types of resets and the difference between them. Right? This chart will help your understanding better and it makes the thing simple. Yes, Mukesh, you can go on.
So, ma'am, right now I am getting your points. So, when will I adopt? Then I asked on that time. Okay.
At that time, you can raise your hand. At that time, I'll unmute you.
Yeah. Okay.
Right?
Not an issue.
You are unmuted, like we'll have the backgrounds. Okay. So that is about the reset thing. So we are having some bunch of ideas. Hope this is clear for all of you. You can try out. This is an additional assignment for you for today. Along with whatever we have done, you can also go through and try out different types of resets, right? That will experiment the different types of resets and observe the things, whatever we have discussed in the flowchart, just go through it so that you will get a good understanding on how the reset works. And at this point, I would like to remind you, we were still in the local repository. We did not go to remote yet, correct? See, we were still on this. We did not go to remote, right? So you have to make a note of it. All right. So coming back, I would like to clean up everything. I want this to be the topmost or else I want to discard these two. How do I do that? Finally, I would like to clean up everything. What do I do? Git reset, hard, and I don't want the top two commit IDs, head tilde 2. Right? Gone. I'm just with the initial changes, whatever I have done later or not needed. So I have done a reset. Perfect, right? So that's about revert, reset. let me just summarize what we have discussed so that we'll just revise and proceed to the next part. I'm sorry. Yeah. So we have something like, we started with the diff commands, right? Git a diff file name or git a diff stage. This will show you staged changes. Git a diff will show you unstaged changes. We just started off from here. And then git a diff, and then we did dot git ignore, right? Git ignore concept, why to ignore and how to ignore the files. And then we discussed about revert and the reset. These are the things we discussed. But these are very important in real time. Like from here on, these are very important, right? Even though we don't use the reset, which we use here much, but you should know, you should have clarity on it, right? And revert ignore we use very frequently. And like I said, we'll be using git ignore to exclude from version controlling, like files which will have sensitive data, like state files for Terraform, right? All of that will be ignored. So these are the things we discussed. Any questions for anyone in this part? Could you differentiate them, and are you all good with this? Whoever raised hands are unmuted, you can go ahead. Thank you, Ramakrishna, for confirming. All right. So let me know if anyone have any questions or confusions on this. Now let's talk about something called branching. Till now, whenever you are running status, you might be seeing something like on branch master, right? But we did not discuss that till now. Now it's a time. Let's talk about this branch. What is a branch? Why do we need a branch? What is the importance of it, right? Let's get started. So whenever you create a repository, right? Like we created this Git demos repository. Whenever you create a repository, there will be a branch created in the repository. You can imagine branch is like a virtual folder or a virtual directory, like an imaginary one. So whenever you create a repository, there will be a branch created called master. Master branch is the default or the main branch. Default means it's by default present, right? That's called default branch or the main branch or master branch, whatever you call it. And whatever changes you are doing till now are set to be in the master branch, right? Like I have created some files like file 1, file 2, everything will be in this master. Whatever commits you are making, like commit A, commit B, I can't write the alphanumeric, so I'm referring them with letters. So all of them like were all on the master branch, right? So now let's say we are working on some requirement 1. So you're making these changes. There is a client came up with another requirement 2. We have to modify the same files here also, right? Same files here as well. Some changes might be different. And at a later point of time, I have to release this for May. Release means you have to push this to production or make it available for end users by May. You have to provide this by July. So if you are just keeping everything is in the same folder, imagine we are placing everything in the same master branch. So how do you segregate them? How do you differentiate, and how do you push them separately, right? At some point of time, you don't understand which changes are for requirement 1, which changes are for requirement 2. Am I correct? So if you are just modifying the same folder for different changes, we can't segregate which changes are for requirement 1, which changes are for requirement 2. At the same point, at the same time, I can't push them separately, right? So how do I achieve this? How do we do this? That's where comes something called like as you can't segregate it, we will be just creating a copy of the master branch, which is called B1 branch, right? You create a copy of this master with a B1. right? So you create a copy. When you create a copy, B1 is like a copy for master. So what do we do here? You get everything, the files, the commits, everything copied, and you are creating this folder. Right now, instead of making FR2 requirement 2 here, what we'll do is we'll put the next requirement changes into this folder. Rather than making changes everything into a single one, we'll publish them separately. Right? This is for July release. So that changes are segregated. We can have parallel development, parallel releases, right? That's the importance of branch. It's the same at the time you create it, but later on they work like parallel entities. Means if you make any change here, this will not be visible to master. Similarly, if you make any changes here, it will not be visible to B1. It works like two separate folders, separate entities. So that what are the advantages? It can allow parallel development, right? You can work on multiple requirements, right? Or else that's one use case. Another one, you can have multiple releases, right? Multiple releases can be handled this way. You can also have another reason is you can maintain different environments like a dev environment, staging environment, prod environment, and all with different branches. Or else, let's say there is some bug fix, quick bug fix, create a separate branch, fix it and release it. So for bug fixes, we may create a separate branch to maintain different environments or different versions. All of these use cases are for branching. Branching is the one which is used in real time, and branching strategies of Git are so famous, which made Git so widely used. What is a branching strategy and all, I'll explain. Here I'm just explaining you the concept of branch. Understood the concept of branch? Any questions? To make this concept more simple, okay, I would like to give you a very simple example. Let's say I'm just writing some story. Okay. Right. Now, let's say I want to give some climax to the story. I don't want to mess up the original one. Maybe I have a different thoughts, different climax. And so what I'll do, I'll just make a copy of this. Right. So till I make a copy, both are same. But now, if I make some changes to this story too, would it be reflecting in story, the original one? Will the original one be impacted? Please be attentive, do respond so that we can have interactive sessions.
No, madam.
Right, it's not visible. They work like two parallel things from now on. I may give a different climax here, I may give a different climax here. They work like two parallel entities. Initially, it was a copy. Initially, it was same, but later on, if I make something here, it won't be automatically visible on story or the vice versa. Right, they work like two parallel entities. I may provide both of them to publishers. Publishers, whichever they want, whichever they like, they may publish it, and means the other one you can just discard it, delete it. Or else they may be publishing both of them, right? They want both the stories. So that could be another scenario. So coming back, your branches could be permanent or temporary. Like let's say, like I told you some use cases, right? Like Just a second, I'm trying to pull up the drawing which we had some time back. Okay, so branching could be temporary purpose or permanent, right? Like meaning, let's say it's for environment. I want to maintain a separate branch for dev, prod, staging and all. Yes, we may keep the branches as permanent. Or else I just want to test some changes. I may use it like a draft. Once I'm done with it, I may integrate those changes back to the original branch and delete that temporary branch. It could be for various purposes. Branches could be for various purpose, various reasons. We'll talk more about that. We'll go through those scenarios and use cases, right? But yeah, that's the purpose of branch. Branch is like a copy. It's like a virtual folder in your local repository. And you may have for different releases or different environments or different users may create their own branch and work on it. And later on, they may merge to original branches and delete those draft branches, right? So that is the concept of branch. I believe it's clear for everyone now. Anyone having any questions, let me know. See git status. Also, you can see branch list this way, git branch. It will list the branches, only one branch. ls and status, all of this with respect to this master branch. Now let's create a branch which would be a copy of the master. Good to go? How do you do that? Git branch, syntax is new branch name and the old branch name or the parent branch. Parent branch means from which branch you're going to create this, right? So git branch, B1 is the new branch or the child branch and the parent is master. So it means B1 branch will be created, which will be an exact copy of master, right? So yes, branch is created. You may check it in the branch list, yes. But there is star, asterisk symbol indicates you are on master branch, right? We are on master. Branch is created, but you are still on master branch. See, let's suppose you want to move it. Okay. Yeah. So you just want to move it to switch to other branch, right? Let's say, how do you switch? Git checkout B1. Checkout is the command to switch the branch. See, you switched the branch and status shows you are on branch B1. It's just virtual folder. The concept, commands, everything remains same. And also, if you see the branch list, see asterisk is on B1, means you are on B1. If you do ls, it is set to be on B1. Any command now is set to be on B1. Status means you are on B1. You are checking the status of B1. Perfect, right? You got everything. You got the files copied from master. You should also see the log from master copied into here, into this branch. Log means log of B1. See, this is the log of B1 copied from master. You got the commits copied. You got the files copied. So a separate branch B1 is created. Now I'm going to create a file on B1. Can I get into it? Or any questions before I proceed? Appreciate your quick responses. Thumbs up will help me, or the chat window, whatever. Can I go on? Right. Thank you. Thanks for confirming. Now, let me just create some file here. Now, this is all B1, right? Let me create some file 3 on B1. Okay. Hello from B1. Some dummy lines I'm adding. Same old story. Where is the file now? I mean, whether it is in the staging area or local repository or working directory. The concept is same with respect to B1. Everything is with respect to B1. See, on branch B1 again untracked. What we should do? Correct? Add it. Status. Changes to be committed. Means where is the file? Of course, file is on B1 branch, but whether it is in working directory or staging area or local repository.
Staging.
Staging area. So let me commit git commit -m on B1 or from B1 kind of message I'm giving. Done. Now, ls, 3 files, git ls files, 3 files, git status, everything is clean on B1. Now, I have a question for you. Do you think we will have this file 3 and third commit on master branch? Do we have that on master branch?
No.
No.
Definitely no, right? It's like a parallel entry. Let us check it out. Let us go to master. How to switch the branch?
You check out.
Check out master. Now I'm on master branch. See here, Explorer also shows you files on which branch you are on. I'm on master now. See, only these files and also commit. I wouldn't be having this commit. Let me run the log. See, log of master is only this. Now if I run log command or status command, it is applicable for master because I'm on master. But I'm on master, but still I want to see the log of B1. This is the command. See, there is a third commit on B1 which is not there on master. So it's like two parallel entities is what I want to show you. Is this much clear for everyone? Interesting, isn't it? This branching strategy or branching concept is very, very important. Our pipelines depends on these branching strategy. I will talk about that. We are going to build our pipelines for dev, staging, different environments. We'll see how it navigates from one environment to environment. All of that we'll be talking about. Okay. And another thing is at this point, hands-on is a mandatory. I want every one of you to go with the hands-on after doing this, like particularly this session, the branching or not. Just checking for the browser. So here are the lab assignments. You may go here or else from your LMS, like go to that window, like where you have your learnings and go from there. It's up to you. But here you are expected to do this hands-on. All of them were here. Whoever haven't have this, I'm just showing you so that you don't want, I don't want anyone to miss on this hands-on. Hands-on is mandatory, okay? Just if you listen without hands-on, it wouldn't work. You have to do the hands-on. Any questions, any doubts you have to post them in the group so that will help you out. This is what we discussed today. Git diff, git rm cached, git ignore, right? Revert, reset, different types of reset, differences between revert and revert. These are the topics we discussed. We did not discuss merge yet. Okay, we will discuss that and topics listed here. And if you just go, you have all the explanation, differences between revert, reset, everything you can revise before you coming to the next class, because we are stepping into much more advanced concepts from tomorrow. Right? And also this is the quiz for day 2. You all have access to this LMS by now. You can go through it and complete your quiz. Also, just do the quiz now as well as like after the class, like after listening the recording also, once again, do the quiz so that you could revise. I mean, you could see an improvement. Whatever we have discussed today, the commands were listed. And the Git recording session will be available in here as a Git 2. Right? So that's how parallel development is achieved. This is for the purpose of branching. I don't want to go to merge today, right? I want you all guys to do some hands-on and then we'll go to the merge part. Last 15 minutes we'll have for questionnaire every day. As you do the hands-on, you get a lot of questions. That's how we can proceed. So let's get on to the questions if you have any. Any more questions from previous classes, like yesterday's class or today's, anything you want? You can go ahead now. LMS link. Okay, this is your LMS. Any more questions from anyone?
No.
Like there is next part is, okay, we have done something in the B1 branch. Suppose I want to bring changes, integrate changes from B1 to master. That's where merge comes in. Again, there are different types of merge, right? Merge with conflicts, without conflicts and all. I would like to put that topic for the next class. Any more questions from anyone? All right, if no questions, we'll close it here. Go with and see you all tomorrow. Have a good day. Bye, everyone.